Hello guys, welcome to Solving Solutions, your Unbound channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's video, we are going to look at nearest neighbor analysis in GIS. Now we have a few notes before we start the demonstration in full. We say the nearest neighbor analysis or neighborhood analysis is a spatial analysis technique used in GIS and spatial statistics to examine the distribution and arrangement of features within a data set based on their proximity to one another. Right, good. Now there's a key phrase here: proximity to one another. Now there are different ways we can use the distance to nearest hub, proximity analysis, distance matrix tool, Python scripts, Saga GIS tools, right? Good. However, on today's tutorial, our focus is on what this distance to nearest hub, right? So on our data here, or as our data here, we have some points, or we have some points, one of which are banks, and then the others are what are places, right? Good. So if we open up this attribute table, we are going to just move up to names where we can see. Good. So these are what some locations, right? Good, within River State, right? Good. And then these are also some banks that are within what River State, right? Good. So these are also some banks that are within River State. They were actually downloaded from a composite data and then sorted out. So the tool we said our focus is the distance to nearest hub, right? Good. So we come to the processing toolbox and then we search for what distance to nearest hub, right? Good. It's actually under vector analysis. So we have that of line to hub, and then we have what points, right? Good. We're actually interested in what the lines to hub, or let's say line to hub. Now, given an origin and the destination, layers, this algorithm computes the distance between origin features and their closest destination one, right? Good. Now, distance calculations are based on the feature center. The resulting layer contains line linking each origin point with its nearest destination feature. So we are going to what, according to the description we have seen here, we are going to create a distance from the banks to what their nearest neighbors in this point in this, let's say, places layer, right? Good. So our source layer should be what the banks, right? Good. Then the destination, which is the hub layer, should be what the places, right? Good. We actually add this River State shapefile for validation, right? Good. So given an origin and the destination layers, the algorithm computes distance between origin features, which in this case are banks. Yours might be hospitals or maybe other public facilities, to where maybe the nearest distances where people can come and maybe benefit from those facilities, right? Good. So the hub layer name attributes, we are going to use what the name field, right? Good. So the measurement units, let's use kilometers, right? Now one other thing I have actually done is that I ensured that the CRS on the both layers are actually what projected, right? Good. Zone 32 here and then zone 32 here. I would not know if it has any effect, but one thing is that if it were geographic, the units would have been in what latitude and longitude, which would not mostly allow you to perform linear analysis, right? So it's always best you leave it on a projected CRS. Then let's give it what an output folder. Now under the hub distance, we can decide to save as a temporary layer or maybe save to file, right? Good. So we are working on a folder called we have neighborhood analysis, and then let's call this let's call it distance to hub, right? And then we click on save. So basically we have imputed the parameters on the source point layer, the destination hub layer, the hub layer name attribute, the measurement unit. We have also indicated what the output directory, right? Good. Now we can decide to run. Good. So we have what our layer out. We can actually do well by changing the symbology so that we can see something brighter. Let's use black. Then let me make this 1. Right, good. So apply and then okay. So we have some lines somewhere there. We can zoom to layer. Good. Now we can also decide to display the layers, the labels rather. So we come down to single labels. Prefer using Times New Roman. Let me make it bold and then let's make this about 7 or 8, right? Apply. And then okay, the field we want to use is name. Good. Apply. Then we click on OK. Similarly, we can do the same for the banks. Good. So you can now see that from each of the banks we have what lines that are okay. Let me reduce the thickness of this our symbology. Let me make it 0.5. I think 0.5 will be better. Good. From each of these you see, from each of these banks you can see the distance to what the nearest settlement, right? Good. Where we have some places. This also comes up to takes us to the attribute table. Let's open our attribute table. Now on the attribute table there are 2 new fields that are created, right? Good. Now the hub name and then the hub distance. Remember that we use them kilometer as the unit, right? Good. So now this hub name shows that these banks are actually moved to this hub at this what distance. So if we decide to just zoom to selected row, we are going to see now that we have from Diamond Bank, we have moved, or the nearest distance was to what this Elungu community, right? Good. So similarly, people that are from this community can also access EcoBank. People from this community can also access what UBA, right? Good. So this is a spatial analysis techniques used to examine the proximity of features in a spatial data set. So the proximity here is the closeness from each of these banks to the different settlement, right? Good. So you can actually use the same approach for maybe incident points. Maybe if there are some accidents, you can just from those different accident points to the nearest settlements where likely people would have been coming from, or maybe if you have hospital, or maybe if you have school or any other public facility, right? Good. So you can see now that this community Ogunigba is actually being linked to these banks, right? Good. So if you are able to identify each of these lines, you can come up to the attributes table here to know what their distances, and of course you are also going to identify what the hub name, right? Good. So this is a simple demonstration of how you can carry out neighborhood analysis or nearest neighbor analysis using the distance to hub tool, distance to nearest hub tool, right? Good. Distance to nearest hub tool in QGIS, right? Good. So if you have any question, comment, contribution, you can actually leave it on the comment section and we are going to get back to you as soon as possible. So if you also want us to help you do something like this, you can rightly reach us via the contacts being displayed on your screen and we'll help you fix it as soon as possible. So until we see you on our next video, ensure you keep staying safe and have a very good time. Bye.